The ESO Supernova Planetarium and Visitor Center is a remarkable place. It stands in Garching, near Munich, in Germany. It is not a star that has exploded, instead it is a center for discovery. It invites us all to look up, to wonder about the vast universe that surrounds us. This amazing building with its unique design looks like a close binary star system. One star is transferring mass to its companion. This is a hint of the cosmic dramas it helps us understand. It's a gateway to the cosmos for everyone. A supernova, the real kind, is a star's grand finale. It is an explosion of immense power. For a short time, a single dying star can outshine an entire galaxy. These events are incredibly important. They scatter heavy elements across space, elements like iron, gold, and silver. These are the very building blocks of planets, and indeed the building blocks of us. The ESO Supernova Center uses stunning visuals and exhibits. It brings these distant, powerful events closer to home. It helps us grasp their significance in the cosmic story. Observing actual supernovae across the universe is vital for astronomers. Each explosion is a unique laboratory. It allows scientists to test their theories about stars, how they live, how they die, what they leave behind. These cosmic beacons tell us about the universe's chemistry. They reveal how the elements essential for life are forged and distributed. The light from these explosions travels for millions, even billions of years. It carries secrets from the distant past, waiting for us to decipher them. Understanding them is key to understanding our own origins. The ESO Supernova Center plays a crucial role here. It translates complex astronomical findings into something everyone can appreciate. It is a bridge between the cutting edge of science and public curiosity. Through its planetarium shows and interactive displays, it sparks imagination. It encourages young minds to ask big questions. Questions about space, about time, and about our place within this grand cosmic tapestry. It reminds us that the universe is not just for scientists, it is for all of us to explore and to marvel at its beauty. Supernovae do more than just tell us about stars. Some types, called type Ia supernovae, have a known brightness. They act like standard candles in the dark. Imagine you see a candle in the distance. If you know how bright that candle truly is, you can tell how far away it is. The dimmer it appears, the further away it must be. Astronomers use type Ia supernovae in a similar way. They help us measure the vast distances between galaxies. This ability to measure cosmic distances has led to profound discoveries about the universe itself. These measurements revealed something astonishing. The universe is not static, it is expanding. Galaxies are moving away from each other. It is not that they are flying through space, rather space itself is stretching. Think of dots on the surface of a balloon. As you inflate the balloon, the dots move further apart. The fabric of the balloon itself is expanding. This was a revolutionary idea. It changed our entire understanding of the cosmos. Edwin Hubble was one of the key astronomers whose observations confirmed this cosmic expansion. If the universe is expanding, then it must have been smaller in the past, much smaller. If we rewind this expansion, everything comes closer together. Go back far enough, about 13.8 billion years, and everything was in one place. All the matter and energy of the universe, it was an incredibly hot, incredibly dense state. This was the beginning. We call it the Big Bang. It wasn't an explosion in existing space, it was the beginning of space and time itself, a moment of creation for everything we see around us. Facilities like the ESO Supernova help us connect these ideas. They show how the death of stars, supernovae, provides the tools to understand this grand expansion. They help us visualize the immense journey from that initial tiny point to the vast cosmos we observe today. The light from distant supernovae tells a story. It's a story of change, of growth, and of a universe constantly in motion. By studying these echoes of stellar death, we learn about the birth and life of the entire universe. It is a beautiful, interconnected cosmic dance. For a long time, astronomers thought the universe's expansion might be slowing down. Gravity, after all, pulls things together. The combined gravity of all the galaxies should act like a brake. It should gradually slow down the expansion. Perhaps it would even cause the universe to collapse back in on itself one day. This seemed like a logical assumption. Scientists set out to measure this expected deceleration. They used those reliable type Ia supernovae, looking far back in time to check. However, the universe had a surprise in store. In the late 1990s, observations of distant supernovae showed the opposite. The expansion of the universe is not slowing down. It is accelerating. It is getting faster and faster. This was a truly profound discovery. It turned our understanding of cosmology on its head. Something unknown, something powerful, must be counteracting gravity. It must be pushing the universe apart at an ever-increasing rate. This was a puzzle that demanded a new kind of explanation. Scientists gave this mysterious force a name: dark energy. We call it dark because we cannot see it directly. It does not interact with light. It does not seem to interact with ordinary matter in any way we can easily detect, except through its gravitational effect on the universe as a whole, a sort of anti-gravity. It seems to be a property of space itself. As space expands, more of this dark energy appears, pushing the expansion even faster. It is like a gentle, persistent pressure filling all of cosmic space. Dark energy is one of the biggest mysteries in science today. It makes up about 68% of the total energy density of the universe. Normal matter, the stuff that makes up stars, planets, and us, is less than 5%. Another 27% is dark matter, also mysterious but different from dark energy. So the vast majority of the universe is made of things we don't fully understand. Observatories around the world, including those operated by ESO, are working hard. They are trying to unravel the nature of dark energy. Its discovery has opened a new chapter in our cosmic exploration. The discovery of dark energy, and the accelerating expansion, changes how we think about the universe's ultimate fate. If this acceleration continues, what will happen in the far, far future? Will the universe end? And if so, how? Several theories try to predict the end of our cosmos. Each depends on the exact nature of dark energy, which we are still trying to understand. These are not just abstract ideas, they are the possible conclusions to the grand story that began with the Big Bang. One leading theory is called the Big Freeze or heat death. In this scenario, the universe continues to expand forever. As it expands, it becomes colder and emptier. Galaxies will drift so far apart that they become isolated islands in an endless void. Stars will eventually burn out. New star formation will cease as the raw materials run out. Even black holes may eventually evaporate over unimaginable timescales. The universe would slowly fade into a cold, dark, and lifeless state, a quiet and drawn-out end. Another, more dramatic possibility is the Big Rip. This theory suggests that dark energy might become even stronger over time. If it does, its repulsive force could eventually overcome all other forces. First, it would tear apart clusters of galaxies. Then, galaxies themselves would be ripped asunder. Stars and planetary systems would be unbound. Eventually, even atoms themselves could be torn apart. The very fabric of space-time would unravel. This would be a violent end, with everything shredded into its most fundamental, disconnected components. Studying these distant possibilities might seem far removed from our daily lives, yet it speaks to a fundamental human desire. We want to understand our origins, our present, and our ultimate destiny. The journey from observing a supernova, like those showcased at the ESO Supernova Center, to contemplating the end of everything, is a testament to human curiosity. It shows our capacity to explore the universe with our minds and our instruments. Understanding these cosmic scales, from stellar death to the universe's fate, helps us appreciate our own fleeting, precious moment in the vastness of time.